Hello, this is Mrs. Boots, and in this video we're going to work through our practice problems for the applications of logs. So with each problem, the first thing we need to do is identify all the different pieces for our problem and which equation that we're using. So notice if it says compounded quarterly, monthly, something like that, we're using the y equals a times 1 plus r divided by n, all raised to the nt power. So let's read our problem and identify what each of the pieces is. So 800 is invested at 6% interest. So 800 is what we started with, and our interest rate is 6%. So that's 0.06. It's compounded quarterly. Remember, that's our n value, and quarterly means 4 times a year. They want to know when the balance will double. So I'm looking for time, and double 800 is 1600. Okay, so now let's plug it all into our equation. So I have 1600 equals to 800, parenthesis, 1 plus r, which is 0.06, divided by n, 4, raised to the 4t power. Alright, so here's the tricky part. Remember, we need to divide by the 800 first. That's going to be super easy because 1600 divided by 800 is just 2. So I have 2 equals. The next thing we're going to do is take this wonderful stuff inside the parentheses and get a single number for it. So if I take that and put it in the calculator, what I get is 1.015. So this is now 1.015 raised to the 4t power. Easy enough. Okay, now we got to solve it though. That's crazy. How do I get rid of an exponent? Well, the opposite of exponent is log. So remember, we start with the base. I go across the equal sign, and then I set it equal to my exponent. So I'm going to have log of what? My base is 1.015 of 2, and that's equal to 4t. Now my t is actually almost isolated. What else would we do? We would divide by 4, right? The whole thing gets divided by 4. So when I plug that in the calculator, and we could use change base or you could use the regular. So let me write out change base just in case you forgot. Remember, the base goes to the bottom, so I'd have log 2 divided by log 1.015. I'm going to hit enter and get that answer and then divide it by 4. When I do that, I get a t value of 11.64 years. So my answer is 11.64 years. Number 2. Again, we're dealing with the same equation. Y equals a, parenthesis, 1 plus r divided by n, all raised to the nt power. So let's read our problem and find out what each of our pieces is. 2,000 is invested at 7%. So 2,000 is my starting amount, and 7% is my R value, 0.07. It's compounded monthly, so that's 12. N is 12. When will the balance triple? So I'm looking for T, and triple 2,000, I just multiply by 3, and I get 6,000. Now let's plug them all in. 6,000 equals 2,000, parenthesis, 1 plus 0.07 divided by 12 raised to the 12t power. First step is to move that 2,000 over. It's going to cancel on the right hand side, and 6,000 divided by 2,000 is 3. We're really not surprised by that. But now let's find out what's in the parentheses raised to the 12t. Remember, we're plugging this whole number into our calculator and getting one number, which is 1.015. 0.005. Now I have to solve for the exponent. To solve for an exponent, I turn it into a log. So I start with the base. My base is 1.005. I'm taking the log of 3, and that's equal to 12t, my exponent. Now I need to do my change base. So I have log 3 divided by log of 1.005. And we're going to divide by that 12 to get it onto the other side. So what is that going to equal to? Well, when I plug it all in, I get 15.74 years. So in 15 years, I will have tripled my money. Number 3. Number 3 is a growth and decay. So my equation is slightly different. Remember, it's y equals a, parenthesis 1, plus or minus my rate raised to the t over d power. Let's figure out what each of the pieces is. So our population of 450 animals decreases. So I know I'm using the negative sign, and my population started at 450. It's decreasing at a rate of 16% per year. So 0.16 and per year tells me D is 1. How long time before there's only 100 animals? Okay, so I'm looking for time again. Let's plug in what we have. So 100 equals 450, parenthesis, 1 minus. Remember, we're minusing because it's decreasing. 0.16 raised to the t over 1 power. Now, do we have to write the over 1? No, but we're going to simplify some things. First thing we need to do is divide by that 450. Okay, so divide by 450. I'm going to write this as a fraction. That would be 2 over 9 equals, well, what's the stuff in parentheses? 1 minus 0.16. Well, that just gives me 0.84. Easy enough. And it's raised to the t power. Well, now we're ready to do our log. We start with the base, go across the equal sign, and come back and set it equal to our exponent. So I have log base 0.84 of 2 over 9 is going to be equal to t. The cool part is we don't even have to multiply or divide by anything to get t by itself. So when I use change base to plug it into the calculator, I would have log of 2 divided by 9, all of that's on top, divided by the log of 0.84. Yes, you could have gotten 2 over 9 as a decimal. That would have been fine. And I get 8.63 years. Okay, that means that in a little over 8 years, your population has now reached a critical point in which it is on the endangered species list. And that's a problem. Actually, I think it gets on the endangered species list long before it gets to 100. Let's look at number 4. Which equation are we using? Well, it says continuously, compounded continuously. So that means I'm using part. Y equals PE to the RT. Remember, E is just a button in the calculator. So let's find out what all the other information is. Instead of an A, we actually deal with P in this equation. It's still the same thing. It's the amount we start with. So what did they say? Mr. Campbell invested $6,500. That's how much we start with. At an interest rate paying 6.5%. So 0.065. It's continuously compounded. That told us E. How long will it take the money to be increased by $1,500? So if it's increased by $1,500, so I have to take my $6,500 and add $1,500 to it. What is that? That's $8,000, right? So my Y value is $8,000. So if $8,000 equal to $6,500, e to the 0.065 t. First step is to get the e by itself, right? You got to get e by itself in order to get t by itself. So divide by that 6,500. It's a little crazy. I'm going to keep it as a fraction again. I get 16 over 13 when I reduce that. And that's equal to e to the 0.065 t. Now remember, to solve for the exponent, I have to turn it into a log. So I start with my base, go across, and have it equal to my exponent. A log with a base e is called ln. So I actually don't have to write the base. So I have ln of 16 over 13 equals to 0.065 t. But since ln is already a button in the calculator, I can plug that in and then just divide by 0.065. And what do we get? We have t equals 3.32 years. So in a little over 3 years, Mr. Campbell is going to increase his money by $1,500. That's not bad. Number 5. On number 5 they gave us the equation, but I want you to realize something. It has e to an exponent. So n is the same thing as y. N0 is the same thing as p, and then k would be the same thing as r. So make a little note to yourself. Even though they're using different letters, it's still the PERT equation. It's not a big deal. So on number 5, population of bacteria. That's not fun. But we have an initial count in the number. Let's read through it. So they tell us the culture of 500 bacteria. So we start with 500. Okay. So then what are we doing? K is 0.068, and they want to know when it reaches 10,000. Yeah, that's a big number. And T is what we're looking for. So we're just going to plug it in. So we have 10,000 equals to 500 e to the 0.068 t. See, it looks exactly the same as the last problem. We divide by 500. What's 10,000 divided by 500? It's 20. So I have 20 equals e to the 0.068 t. Now remember, to solve for the exponent, I have to turn it into a log. I start with my base. Well, my base is e, so that makes it a natural log. Go across the equal sign. ln is 20. And then that's equal to my exponent, 0.68t. ln is already a button on the calculator, so we can just plug that in and make sure we close our parentheses. Then we divide by 0.068. And we get t is 44.05. Now what are the units? Yeah, this one's in hours, okay? Not years, hours. So 44 hours. So basically 2 days. In 2 days, our bacteria will have multiplied by that much. That's why we get sick so quick. Number 6. Number 6 is a crazy problem, but it's actually super easy. So we have a college math class of 32 students. And then there's information telling us that the professor cancels the exam, and then he has this equation that'll tell him how long it takes to get the word out to everybody that it's been canceled. And they said, after how many hours will half the class be notified? So the class is 32 people. So I want half of them notified. That means 16. So 16 is the only number that we're actually plugging in. Everything else stays the same. They already gave it to you. Makes it super easy. Well, maybe. Okay, so now I need to get e by itself. That's going to be a little tricky. I have to get rid of all the stuff in front of the e. Well, we cannot subtract the 32 and the 32 and get 0, okay? This first 32 is adding, so we're going to subtract it to get to the other side. So now I have 16 minus 32. That gives me a negative 16. equals negative 32 e to the negative 0.02 x. Okay, so we're still trying to get e by itself, so I gotta get rid of the negative 32 at the front. It's multiplying, opposite of multiply is divide, so I divide by negative 32. So negative 16 divided by negative 2 is a positive 0.5. And that equals to e negative 0.02 x. Now my e is by itself. So we're going to have to turn it into a log. So log with a base e is ln. Go across the equal sign. I get 0.5, and that's equal to the exponent, negative 0.02x. So I'm going to end up dividing by that negative 0.02. And I get x equals 34.66 what? Hours. And the equation tells us hours. So a day and a half, it takes 34 hours, 35 hours, so a day and a half for half the class to find out. So if it's Monday morning, it's all day Monday, half a day Tuesday before half the class finds out. So what do you think it's going to take for the other half the class to find out? Yeah, we're going to have people show up for the exam then find out that it's canceled. That's kind of a bummer. Okay, number 7. So we have a power supply that decreases exponentially over time. And they give us this beautiful equation. So the only thing we have to find is either P or T. And they tell us we're looking for the number of days. So we already know that time is what we're looking for. Because it says after how many, determine the number of days it will take for the power supply to be less than 30 watts. So we're going to find out where it's equal to 30 watts. And then we know after that time period, it'll be less than 30 watts. Okay? So I'm going to plug in 30 for P. So I have 30 equals 50. E to the negative t divided by 250. Yes, that's a huge number. Remember, we want e by itself, so we're going to divide both sides by the 50. And yes, I'm going to keep it as a fraction. You can do it as a decimal. So 30 over 50 is just 3 over 5. That's e to the negative t divided by 250. Now we got to get it into a log in order to get our exponent isolated. So natural log is the log base e. So I have natural log of 3 over 5. Come back, and that's equal to negative t divided by 250. Now how do we get rid of that 250? Well, it's dividing, and the opposite of division is multiplication. So I'm going to multiply by negative 250. Both sides, negative 250. Alright? So let me rewrite this just so it's clear. So I have negative 250 ln of 3 over 5. That's equal to t. That's what I'm plugging into my calculator. And when I do that, I get t equals 127.7 days. So that means at 128, it's going to be less than 30 watts. Number 8. So again, we're looking for T. You see a pattern here. We're always looking for T. Okay, so we have a fossil that contains 47 milligrams of carbon-14. So this is our carbon dating. So which part is our beginning? We'll see this A sub 0. That's what we start with. Anything sub 0 is an initial value. So it has 47. We're using our carbon-14 dating formula to determine the age. Oh, so they said it originally contained 93. So 47 is what it has now. 93 is what it started with. Okay, so we start with 93 and then we have the 47. Not too bad. Let's plug it in. So I have 47 equals to 93 parentheses with a 2 raised to the t over 5,570. Guess what we got to get rid of first? Yep, that 93 in the front. Move it over. 47 over 93 is approximately 1/2. Okay, so we could round it and call it 0.5. And then we have 2 to the t over 5570. Alright, so remember, because we're solving for exponent, we got to turn it into a log. My log has a base of 2. Go across the equal sign, get my 0.5, and that's equal to my exponent, t over 5570. Now to get rid of that 5,570, yeah, we're going to multiply by that number on both sides. So we could plug it in, 5570, parenthesis log base 2 of 0.5. And the funny part is we get t equals 5570 years. Now how do we get that? Well, here's a fun fact. The base is 2 and the argument is 1/2. So 2 to what power equals 1/2? Well, that's just -1. So when we divide, we end up with the exact, or when we multiply, we end up with the exact same thing. And there was a negative sign in front of that t that I missed all the way through the problem. That's why the negatives canceled out. So that should be a negative 5507. This concludes all of our practice problems for log applications.